recording. So, okay. Hello everyone. I guess we can get started now. Welcome to the Nucleotide Hackathon 2020. We had a hackathon called Helix back in April, and we wanted to come back and redo it and make it better and have another experience with the hackathon. So yeah, welcome to Nucleotide. This will be from December 4th to December 7th, and you guys will get an opportunity to code some pretty cool projects with our secret theme, which we'll reveal later on. Okay, so before we get into it, kind of like a brief discussion points, I guess. We're first going to be talking about introducing me, Andrew, and the whole team that's been behind making the hackathon something. Then we're going to talk about like sponsors, and we're going to talk about the concept of a hackathon for those of you who are new to this, because I know there's several of you who are, and then just what to expect, schedule, then just some general logistics. But yeah, nothing much. Okay, so I guess I'll start off by introducing myself. Hi, I'm Yash. I'm the co-executive director of the Nucleotide Hackathon. I'm the chief technical officer at Helix, and most of my work involves artificial intelligence, machine learning. So this is all in my ballpark, and I'm really excited to be here. But yeah.
Hi, my name is William, and I'm also the co-executive director of the Nucleotide Hackathon, and I'm currently the CIO of Helix. And most of my work also deals with machine learning in bioinformatics, namely microRNA in breast cancer detection. So I have some experience in this topic as well.
Hi, everyone. I'm Andrew. I'm in charge of marketing for this hackathon, and I'm interested in bioinformatics as well, such as microRNAs and cancer, like William.
Hi, I'm Sarah. I'm the head of the outreach for the Nucleotide Hackathon. At Helix, I'm the director of events, and I worked on getting more diversity in this hackathon. We have over half of our participants, which are girls, which is a great increase.
Yeah. And then two other shout outs. So I don't think like this would have been possible in terms of our marketing team, but like our ambassadors, Eric Zhao and Stefani Strake, were really helpful in getting more people and getting referrals. So yeah, good job to that. All right, cool.
So we would once again like to thank our sponsors for making this event possible. Without them, we wouldn't really have anything to distribute, and our event would not be possible. So our sponsors include Echo AR, Replit, Wolfram, Sashido, VoiceFlow, Cascade, Balsamic, Qualm, Makey, Sublime Text, Bugsy, and 1Password. And you can, if you go to our hackathon website, which is just nucleotidehack.com, you can find the links to all of the sponsors if you click on the icons, and you can check out all of their products if you want, because many of the products involve programming or making your life easier in like app development and things like that. So yeah. Next slide.
Andrew, do you want?
Yeah, so we wanted to take a quick minute to share with you a special opportunity because we know that many of you are interested in biology or research or computer science. So if you're interested in those, you should definitely check out the Research Science Institute, or RSI. So it's a summer program that is completely free to all students, regardless of financial situation. And every year, 80 students who apply get picked to gather at MIT in Cambridge to participate in this program. And it's basically like a research mentorship that you live on MIT, I think. And there's you learn a lot. There's a rigorous coursework, research mentorship, and overall, they say it's an unforgettable summer with other students who are highly passionate about STEM. And if you're from an underrepresented group, you're really encouraged to apply. The application is due January 16, and you can see it at bit.ly/RSI2021 and send questions to maite@cee.org. It's a very well-known program, and it's completely free, as I mentioned. So it's a great experience. I know some summer programs out there are like $10,000 for 2 weeks at like a fancy university, but RSI is really known as one of the most like high quality science research program out there for high school students. So domestic students can apply, or if you're international, you could also apply. But there's a little bit more steps involved in that, and you should check out their website to see what you should do if you're an international student.
All right, thanks, Andrew. So I guess back to the hackathon and this weekend. So this weekend you guys will be engaging in like coding your own projects, which are going to abide by the theme that we're going to reveal later on. And throughout the hackathon, you guys will be working in teams or solo or to develop essentially any kind of website, app, even hardware sometimes. Last time we had in April, we had a few hardware submissions. So even that, and then you'll be following the submission requirements and then submitting it, which we'll also talk about later. So overall, you'll leave with you'll leave with like some collaborative experience and new connections, because like I know I've talked to some of my hackathon teammates from other like events, so it's really cool to like just collaborate with these teammates, and you leave with some like connections. Secondly, you'll leave with this creative coding project under your belt. And remember, after you leave with the code, after you like code your project, it basically it signs to your name, and can be really helpful in the future for opportunities and other things like that. You'll also leave with some knowledge from the talks from the experts that we're going to present. So our first talk, which will be pretty much directly after this, will be from Dr. Kuo, who works in bioinformatics and has a lot of like publications under his belt as well. And then we'll also be doing things like a workshop, to strengthen coding knowledge and things like that. So overall, lots to come out of this, and we'll also talk about the prizes.
Can you go back for a second?
Yeah.
I just have something to add. So one thing we made an exception for this time is we are allowing people to work individually. So obviously collaboration is encouraged because you get to meet new people and you'll probably get more done. But a lot of people have expressed interest in working alone. But if you're looking for a team, there's a channel specifically for finding teams. And a lot of people have been posting their like fields of interest, their experience. But I feel like the best way to actually find a team, if you are looking for a team this hackathon, is to actually DM some of those people that you see with like similar interests or similar strengths and things like that. So yeah. Next slide, please.
Okay.
So our hackathon will include 3 days of hacking and a total of around $250,000 in prizes after recalculation. And many of these prizes are just for signing up. So even if you don't win, since there are a lot of people competing, you still will get prizes just for participating. So, and those are like emailed to people that have registered. So we have an email list of all the participants, and I have already emailed those. And so if you didn't receive the email, it's probably because you signed up afterwards, after the time I sent the email out. And I will be looking for like any people that signed up recently right after this meeting. So don't worry, I will forward those emails to you for redeeming those $300+ worth of softwares and prizes just for signing up. And some of these softwares, you will get like a more detailed description in the email, but I just want to mention some of the softwares available. And again, most of these softwares are meant to help you during the hackathon. So a lot of our sponsors express interest in collaborating with us and giving us giving you guys access to softwares in order to enhance your for example app building process or coding process. And these softwares often make your app building process a lot easier. And this is like a great opportunity for some of the people that have less coding experience. So some of these prizes include Echo AR, business tier access for the duration of event. But if you email them at info@echoar.xyz, you can get 1 month business access. Replit gives you a 3-month hacker plan. Wolfram Alpha will be giving you a 1 month access to Wolfram 1. VoiceFlow will give you a 1 month pro package. Balsamic will give you a 3-month extended promotion. Shishido will give you guys $120 worth of credits to spend on their website. And yeah, besides that, there are like many individual prizes, which we will talk about later after. So these are the regular prizes. Some of these prizes actually have really high dollar values. So the first place prize is $100 in cash, Sublime text keys, and these are worth $80 each. And each person on your team will get one password, 6-month access. I believe this is worth like $70, something around that, and $500 worth of Bugsy credits, and you can redeem those to spend on their website. Second place will get $65 cash, 1 password, 6-month access, a Makey coupon, which is worth around $50, and $300 worth of Bugsy credits. And third prize will get $35, 6-month, 1 password access, and $200 worth of Bugsy credits. Additionally, the top 20 teams will receive a 1-year Wolfram 1 personal edition, which is worth around $400, $375. So look forward to that. Yeah, and those are the regular prizes. And some of the sponsors have expressed interest in creating in sponsoring prizes for using their software. So there are 2 prizes, special prizes. One is best use of Echo AR, and one is best use of Qualm. And each of these have their special prizes, but the requirement is that you have to use their software in order to develop your project. So for best use of Echo AR, yeah, Qualm is great. For best use of Echo AR, you can win a $50 Amazon gift card, 1 month free business tier access to Echo AR, and a feature in their newsletter. And for Qualm, you'll get a 1-year starter plan if you win, and you will be considered for the Qualm creator group. So this is kind of like an internship at Qualm, which is something to look forward to. And there will be workshops for each of these softwares and how to use them. So if you're unsure about how to use many of these softwares, we pretty much have a workshop for all the major ones, especially the ones that sponsored us with special prizes.
Yeah, so speaking of workshops, so today we're going to have a lot of events. Today is probably one of the most busy days in the hackathon. But after this, so after the opening ceremony, we'll be hearing a talk from Dr. Kuo about biomedical applications in blockchain. And then at 4:30, we'll be hearing from the Vice President of Artificial Intelligence at Samsung SDS, who will be talking about his route, his path and career path. Then I'll be doing an introduction to Python workshop and essentially just walking the beginners and even more advanced people through a simple project. And then tomorrow at 8 a.m., like bright and early, we'll have Giorgio Kier, who's a very renowned scientist at the Scripps Institute, present. And then at 3 p.m., as Will said, we'll have our sponsor workshops, which are the Qualm workshop, starting off with you'll build a web application. I believe they chose facial recognition or data analysis, but yeah. Then at 5 to 5:40, will be streaming a video from our Echo AR partners to talk about how to use Echo AR and more. And then Sunday, we decided to keep it blank because last time we had people express interest in having more time to hack. So now you have an entire day to hack and make your project. Then on Monday at 4 p.m., the submissions will be due, and then Tuesday we'll have our opening ceremony or closing ceremony.
Just some things to add. We highly encourage you to visit these seminars, even if you're not trying to compete for the special prizes, since some of these softwares are like leading softwares in their fields or in their respective areas. So it's good to know how to use these softwares, and most of these workshops are pretty quick, so it won't take up too much of your hacking time. And also, yes, the times are in Pacific Standard Time, and I know many of you are on the East Coast, so you would add 3 hours to the times. Next slide, please.
So the themes for this hackathon, there are 4, and you can pick whatever one. We wanted to give us a lot of flexibility while still staying within our guidelines. So they're bioinformatics, science education, biology, and research. So I'm going to give a quick example of each one in case you aren't really sure what this means. Anyway, so first off, you can choose any of these 4, and you'll be eligible to be judged. And there's not a separate award for each one. So we're going to be selecting the first, second, and third place from all 4 categories. So there's not like 3 prizes for each subcategory. Anyway, so a bioinformatics project could be like some tool that uses an online database to get you information about a gene. Science education could be making a website that teaches kids about mitosis or the life cycle of a plant. Biology could be similar to bioinformatics. It could be like a visualization of photosynthesis, something like that. And research is any tool, website, app that can help researchers. For example, you could make a calculator for scientists that helps them calculate dilutions, titrations, or a calculator for converting from moles to grams of an element. So these are just ideas. You obviously don't have to do them, but hopefully this gives you an idea of what the topics are.
Oh, okay. So yeah, I guess I can talk about recommended resources. So a lot of you guys are maybe new to programming. This is something that, you're first diving into, and that's great. Like, we definitely recommend beginners coming in because, coding projects is, a really good way to learn. So few recommended resources. First is called Replit. It's an online IDE which supports many different languages. Second is YouTube. Honestly, like, really good programming materials, and it's like sometimes even very specific, how to make like a file upload button, etc. So in X language. So there's a lot of specific stuff there. Thirdly, I'd say go to the workshops. We're gonna have a lot of experts talking. So if anything, it's not even like a bad time trade-off. You'll have, like some potential connections and potential like views into the field. The next is Echo AR, which is one of our sponsors. We highly recommend you use this because this is going to be eligible for the Echo AR prize, as well as Quam. Quam not only is useful for the prize, but it also is a very easy web development software, as Andrew said, that you can use it, on your like computer, or like on your browser. Sorry. So then you can check out like things like Science News, other science news outlets, which or essentially can give you some like bioinformatics ideas, and and anything that relates to the topic. Andrew.
So here's some other resources that we recently launched. So William, Yash, and I recently created 3 free online courses for bioinformatics. So this could be really useful to you. If not for this hackathon, it could be useful for your own purposes, especially if you're interested in science fair, since we designed them to be for helping students who want to compete in a science fair but don't know where to start, right? Like, you can't get in a lab right now. You probably don't have bioinformatics classes at school. So these courses are meant to supplement that. So our first course is gene expression analysis at helix.science/genes. Actually, the links are all available at helix.science/genes. And this course, you'll learn how to analyze online gene expression data just using Google Chrome and Google Sheets. And you'll learn to like analyze genes, analyze groups of genes, etc. In the AI and biology course, you'll learn how to use machine learning to do things like classify or detect breast cancer and malaria and pneumonia. And finally, in our basic Python and bioinformatics, you'll learn how to use Python to do things like convert DNA to RNA, to proteins, and use the BioPython package to analyze sequences of DNA. So really cool stuff, and it's free. And each course is under 2 hours, so it's perfect for a weekend. And you'll learn a lot of really valuable skills right out of the box. So it's at helix.science/genes.
Okay, so yeah, those are some good resources. Something I want to talk about is submissions. I've been getting a lot of questions about these, and I think it's important to address. So the way that you are going to be able to submit is going to nucleotide-hackathon.devpost.com. So this will essentially allow both us and you guys to have a platform in which you guys can easily create a project, type up a little description, have a demo. There's instructions and guidelines on the rules of submission on the dev post. And it also allows us to launch winners, and a lot of hackathons, a lot of even interviews look at things like your dev post. So we want to make sure that it's easier for both us and you guys. So dev post is a really good platform for this. And so we want you guys to submit on dev post. Please don't email us your submissions. So please remember to sign up for dev post. And the submissions are again due December 7th at or p.m.
So there are a lot of, so the organization that's organizing this hackathon is the Helix Initiative, which many of you are a member of. Before we get to the end where I'll share the, oh yeah, you could stay because we're gonna send the Google form for you to enter the raffle. So by coming to this presentation, you're eligible for winning 1 of 2 Amazon gift cards. So you have to stay to the end to get to the raffle, and I'll send a Google form and a password for entering the raffle. So if you're interested in bioinformatics, research, or science, or coding, you should join the Helix Initiative. And I think most of you are already in the server, if not all. So next slide, please. The Helix Initiative, in one sentence, aims to provide science research opportunities for free to youth. I'm as someone, I'm interested in doing science research, but it's always really hard to get internships as a high school student. A lot of the good programs cost a lot of money to go to, or it's really hard to get into them. So we wanted to be able to create our own research opportunities for ourselves using our own knowledge. So to those ends, we've created the Helix Initiative, and there's many ways you can get involved. For one is our chapters program. You can start a Helix chapter, and you can, as a chapter leader, you can apply for grants from us to fund your science outreach endeavors. You can also get free science curriculum from us and request free curriculum to teach your students. We also have other events such as the research program, which is an ongoing science fair mentorship program. Applications are closed, but they'll open up next year in the summer. Other topics that you can take part in include our blog, where you can write articles about science of any science topic you want and get volunteer hours. And furthermore, we have the International Youth Research Summit, which will be of interest to those of you who have done research or plan to do research. This is a 2-day online conference where students will present their own original science research and compete for mini scholarships. At the last event, we had over 60 youth present their research and win over $100 in scholarships or prizes. And we really encourage you to check that out. Sarah can send the link in the chat soon. Next, please. And if you're interested in joining the science blog, you can DM Joanne Lee, editor-in-chief on Discord, or ping her in general Discord. Next slide, please. With that, and other events we do are STEM workshops, such as our workshops this weekend. We had a workshop with 2 neuroscience experts a few weeks ago, and there's always lots of workshops to get involved in. So you should definitely keep the lookout for those. We've done social media information campaigns that have been seen by hundreds of thousands of people, such as a COVID-19 education campaign. We have a podcast, YouTube, and TikTok, although we're currently revamping those. And next. And that's it.
Yeah, so if you guys have any questions, just contact us in the Discord. There's not really a link in chat, but yeah, contact us in Discord, and then we also really quickly threw up this website or this sub website, which is essentially a place where you guys can easily access the links from the calendar. So feel free to check that out. It's nucleotidehack.com/links. So now I will be sending the link to the other Zoom meeting where so now we'll have Dr. Kuo come in shortly and present his work for biomedical blockchain applications. And yeah, so stick around for that.
Yes, Dr. Kuo is an expert in the field of blockchain, so we're really excited that he's taking the time out of his day to speak to us and share about the exciting technology of blockchain and how it can be applied to medicine and health. So I'm going to send the form for the raffle, so please fill that out. The passcode, I'll put it in the chat. So make sure to type the passcode exactly as it's presented in order to be eligible for the raffle. You don't have to enter if you don't want to. Oh, it does? Okay, we'll just put it twice then.
Okay. Dr. Kuo, hello. I'll stop sharing now.
Oh, hi, Yash. Hi, can you hear
Hi.
me okay?
Yeah, hi, how are you doing?
Good, good. How are you?
Good, good. So, okay. Yeah, everyone, this is Dr. Quo. He works in blockchain applications, like specifically in healthcare applications for blockchain. And he's, presented at multiple places, and he's a pretty big expert in this. So, whenever you're ready, Dr. Quo, if you need anything, we'll be here. I can give you here.
Sure, that'd be great.
So yeah, go ahead.
Sure. Can you see my screen now?
Yeah, go ahead.
Oh, great, great. All right. So hi everyone, and thank you for the invitation from Yash. I've been working with Yash since the summer, and he's really great. So so it's my pleasure to talk about a bit about this blockchain technology. And so before I get started, I just want to do a quick poll so I can know you better. Like, if you don't mind, like, how many of you have heard blockchain previously? If so, please put raise a hand or something in the participant list, or put it in the chat box. Okay. All right. Okay, thank you. So I guess I get a bias sampling, approximately probably 50% heard of it, but probably most of you are not very familiar with it. So great. So in any case, I will be giving a very short introduction about this blockchain technology, and then followed by some biomedical applications and some research project that currently I'm working on. So yeah, so again, if you have any questions, please feel free to either interrupt or put in chat, and I'm happy to answer. So so let me get started. So some of you said that you have heard about blockchain previously, but then probably not many of you heard about this healthcare, the idea of applying blockchain in healthcare, because blockchain is such a new technology that its application in many fields are still very kind of like immature. So, but then even though last year, you can see there are many projects already raised more than 600 millions in a single year. And then also some people start to think about how to use blockchain to combat the track COVID-19, this pandemic. So then, of course, if we want to do this, like want to use blockchain to improve, to speed up clinical trials, for example, then of course, the first question will be, how can, what is this blockchain and how can we use it? Why is it important? So blockchain is basically a new way to share this healthcare data, but then again, we want to know how it works first before we can even talk about or think about how to use it. All right, so today I will be talking about a very brief introduction to this blockchain concept. So bear with me because I will simplify many of these details in order not to kind of scare you off. But again, if you have any questions or need any more explanation, please feel free to ask. And then afterwards, I will talk about 3 use cases in biomedical informatics domain of blockchain. So, so let me start with this very high-level introduction. So, blockchain is basically the underlying technology of cryptocurrencies. So, many of you might or might not heard about blockchain, but you probably heard about Bitcoin or its brothers or sister currencies such as Ethereum and others. So, basically, blockchain is the enabling technology beyond this, behind these cryptocurrencies. So a typical blockchain looks like this, a bit scary, but basically it's actually pretty simple. So the idea is, for example, I sent 20 coins to Alice, for example, then this transaction, we call this a transaction, right, of 20 coins will be recorded in a transaction that here we denote it as TX or here T11. And then also there may be other transactions, and then those transactions are enclosed in these blocks. So one block contains several transactions. And then these blocks is then chained by so-called hash value. So some of you might heard about hash, but some of you might not. So hash is basically a simple mathematical, well, not as simple, but a mathematical hash function, a mathematical function that can convert arbitrary lengths of data into a fixed length of data. So a very simple or probably oversimplified example is this mod 10 operation. Basically, we just take the last digit of any number. So as you can see, 123 mod 10 is 3. We just get the last digit. And then for 4256 mod 10 is 6. Very simple. So, but what is the point of using this hash function? So the idea is we can compute from the left-hand side to the right-hand side, but not vice versa. So it's one-way function. So this actually represents an characteristic of fingerprint, which means if we want to create hash of block B1, which means block B1, we should already have the information of block B1, the data of block B1, as well as all of the transactions inside block B1 in order to create this hash so that we can put this hash into block B2. Similarly, to create block B3, the next block, we should already have the information or the data of block B2 ready. So this actually ensures the order of the blocks and hence the order of the transactions. Because as you can imagine, block B1 must happen after block B2 must happen after block B1, right? So that it can include this hash information. So we can infer that this transaction T21 and T22 must also happen after T11 and T12. Okay, so this is like the basic idea of blockchain. So basically, we can imagine it actually looks like a computer scientist data structure called linked list. So this is a linear structure that we can put transactions on it, and then we use this linear structure to determine the order of the transactions. Okay, so so I'll move on. So here, so this is actually the ensured order actually make this blockchain a ledger. So a ledger means that we have a timestamp for each transaction. We can determine which happens first and which happens later. But then how does it work? So how do we create this blockchain? So suppose we have 4 nodes here. We can imagine these 4 nodes as 4 computers or 4 people operating 4 computers, whatever. But then in this network, we only have 4 computers or 4 nodes. So now suppose the people like myself, I'm after node 1, I want to create a transaction TX1, and then some other people in using their own computer want to create different transactions as well. So the first step to create a blockchain is then everyone broadcasts their transaction to the entire network. So now everyone has the same pool of transactions. So now the transactions are yet to be verified, to be committed. They are just shared among the network. So the next step is actually every node start to do a difficult mathematical problem. So this is kind of like trying to solve a puzzle which is computationally intensive. It's very hard. So it's so hard that in average, we can only find a good solution in 10 minutes approximately. So you can imagine that currently using our laptop or even our mobile phone to compute some kind of like a basic numerical arithmetic formulas are actually really fast, probably within a millisecond or even nanosecond. But then this computational problem is so hard that even our computer takes 10 minutes to get a solution. So now every node starts to work on this super hard mathematical question. And then until node 2, for example, luckily find the solution of this mathematical problem. So node 2 is now very happy. So node 2 can have the privilege to create a block and then enclose some of the transactions in the block. And then node 2 broadcast this block to the entire network, claiming that node 2 solved the problem. So then every node check the answer and then make sure node 2 is providing the correct answer. And then afterwards, after node 1, 3, and 4, they all agree with this answer. They basically remove their transactions from the pool because now the transactions are already in a block, transaction 2 and 3. So then they stop mining or they stop their computation because this problem is already solved. So then the next step will be everyone start to work on the next mathematical problem again. So then this time, suppose node 3 luckily get the first answer. So again, node 3 has a privilege to create a block, broadcast to the entire network. Everyone check it. If it is good, stop mining, stop working, and then continue this process. So this is basically how blockchain is built in a nutshell. So of course, I'm omitting tons of details here, but this is like the high level concept. So the idea is, why do we want to do this? It's like sounds like super complicated, right? And then we even need to spend our CPU time to compute a super hard mathematical problem. Why is this helpful? This is because, as you can see in this architecture, there is no central server. So unlike our daily banking, we usually rely on a bank. Either, for example, Bank of America, Wells Fargo, or some others, to help us validate those transactions, to make sure each transaction happens, which transaction happened first, which transaction happened later, and are they valid. But now, using this mechanism, we don't need to rely on a central server, which is extremely important. Because if we rely on this central server, then as you can imagine, if some kind of like online banking system is under maintenance, then actually no one can conduct transactions anymore. So by removing this central server, we can avoid some kind of so-called single point of failure. So the whole system will still work even if one or some of the nodes leaves the network or is not working. So that we call this type of ledger distributed ledger, because now we don't have a central server to record everything, to manage everything. So it's more like peer-to-peer. Okay, so all right. So any questions so far? Okay, I see some question in the chat.
Hi, Dr. Quo. There's people trying to join, but you're host. Is there any way you could just like occasionally let people in?
Oh yeah, sure. I saw that. I just clicked the meet. Thank you. Thank you for reminding. All right, and then I saw a question. Are you looking to run this on quantum computers to get faster run times? That's a great question. Actually, this problem is intended to be hard. So this is kind of interesting. So actually, this problem do not need to be hard, but by our protocol, we intentionally make it hard. So the reason of this is because if creating a block is so simple, anyone can create like 100 blocks in 1 second, then actually people start to have some incentive to create some malicious blocks, right? They can create just some blocks to verify their own invalid transactions and then try to spam the network by sending tons of these malicious blocks. So it is actually our intention to make the creation of block very hard, but the checking of the block very simple. So this is like by design. So yes, of course, if we use quantum computer, we can speed up this computation, but then at that time, we will try to actually make the problem even harder, because we want to make sure even using quantum computer, it cannot be solved immediately. Otherwise, it will defeat the purpose of this distributed architecture. So as you can imagine, actually, we are kind of like wasting some computational time or energy to do this. So the reason of this is because we want to avoid the central server, so that we need additional step to make sure the entire network is secure enough, and then cannot be hacked or attacked easily. So it's like by design, those mathematical problems should be hard. So hope this answers your question. All right, so any other questions so far? Okay, so someone asked, so now I think, what can you use the blockchain for after you create them? That's a great question. So actually, as a ledger, this is the main purpose of blockchain is for, I mean, when we go back to the financial application, it serves as a ledger to solve the problem of embedded transactions. So it's like, since now, so you can imagine if we have a central bank in the middle, then if some people have some kind of like dispute, or they have some problem, like for example, I'm spending my 20 coins twice, right? I send it to Alice and send it to Bob at the same time. Then actually the bank will detect this and will prevent me from doing that. But then, as you can see in this architecture, there's no central server, so no one can actually kind of like serve as this central role to determine which behavior is correct and which is not. So actually, to make sure everything works fine, no one is sending embedded transactions. We set up this blockchain, and then we record everything on chain. So everyone can now serve as a bank, because everyone can see everything, right? Everyone can just check the whole transaction history to determine which transaction should be good and which should not. So actually, this is more like, in a more high-level view, this design is more like a majority voting mechanism that instead of having a central big head, central server to determine who is doing good thing, who is doing bad thing, we now kind of like let everyone vote, and then let everyone see every data and then determine which behavior should be accepted and which should be rejected. So this is the main purpose of using blockchain after we create them. Okay. Okay. Great. So another question is it a possible hardware security threat to have a malicious node recording ledger? Okay, that's a great question. This is actually a detail that I intend to omit today. But yes, in short, yes, we do have a mechanism to avoid malicious attacks. So, and actually, this is kind of very important to the core of the blockchain technology. So the idea is every node, actually, the rule is very simple. The rule is every node will only add new blocks at the end of the longest chain. So, so our assumption is like on this network, we have more like well-behaved node than the malicious nodes. So in this case, actually, everyone will try to try their best to maintain the honest longest chain, so that even if some kind of like attacker want to tweak the content of a blockchain, or try to even create a branch chain to replace the good one, actually, theoretically, it is unlikely to happen, given the assumption that we have more than 50% of good nodes when comparing to those malicious nodes. So this is actually related to a very famous scenario on blockchain, which we call 51% attack. So someone will ask, well, then how about if we have 51% of malicious nodes, then your security design won't work, right? Yes, exactly. So once we have more than 51% of malicious node on the network, then entire thing won't work. But then the point is, again, go back to the incentive. So suppose you can imagine, suppose we are a set of hackers. So we have two choices, right? The first thing is, this is like Bitcoin network, and then we find some way to attack it. And then we take control of 51% of the nodes, and then eventually we break the entire Bitcoin, and then everyone lose all of their money, including myself, because I spend tons of computational power to get 51% of the computational power, and then ends up Bitcoin get bankrupt, get disappeared. So I get nothing, right? So I spend so much time and energy and hardware to get nothing. And then this is the first option. The second option is, since I have 51% of the computational power, why don't I just be a good man? I just silently keep mining to behave well. Then Bitcoin price keep going up, my investment get returned, I get more and more money, right? So this is actually all about the incentive. So theoretically, it is possible for some attacker to like jointly try to break everything. But then later they will soon realize that actually they can make more profit by just following the game, the rule of the game. So this is actually, the design of blockchain is not purely technology, it's also about incentives. So hope this answers your question. All right, so let me just move ahead. So as we just discussed, then people soon realize that Bitcoin blockchain is actually a very interesting technology, because we can also use it not only to store the cryptocurrencies, the coins, but we can use it to actually store data. So how can we do that? So the idea is in each transaction, there is some specific section part called transaction metadata. So it's similar to when we like do some wire transfer to our friend. We can add some small notice at the end, right? This is like your Christmas gift, something like this. So similarly, on blockchain, we can put some arbitrary data in each transaction. So this actually enables a lot of different applications of blockchain, especially non-financial ones. So before I move forward, one thing to notice is that there are actually two major types of blockchain networks. One is called permissionless, and then the other is called permissioned. So permissionless means it's a public network, just like a public internet. Anyone can just join, just like we can just download an app and then join Bitcoin, start to purchase and sell Bitcoin just today. And then the other type of blockchain network is called permissioned. So it's more like a virtual private network, if you heard about it, VPN, like only allowed people can join. So it's kind of like for healthcare or biomedical applications, actually more projects or studies are leaning towards at least starting from permission network, because you can imagine those data could be sensitive. Those might be related to patient, to healthcare, to medical records. So so people tend to be more careful about this sensitive data. So so for most of the non-financial applications, actually people start to build permission network first before moving forward into the permissionless or public blockchain networks. Okay. All right. So so let's move to healthcare now. So actually, blockchain poses several important features when comparing to traditional databases. So the first one is called decentralized management, so that as you can imagine, we don't have this central server, right? And then the second one is its immutability. So as we just explained, actually someone want to modify the block or even create a malicious branch of the blockchain is extremely difficult, given that we have 51% of good nodes. And then data provenance. So now everyone can see everything. So everyone knows who submit what data, what transaction, and what blocks, which ensures the source of the data is verifiable. And then also it's highly robust and available in terms of no single point of failure. Even if we have few nodes get failure, other people can still, other computer can still work normally. So, and then there are some like added security privacy features that for the interest of time, I probably won't be able to cover, but in a sense, these are the key benefits of blockchain. So as you can imagine, this is actually game changing for biomedical and healthcare applications, because now people start to think about, can we use blockchain to improve the way we store medical records now? So as you can imagine, now medical records are mostly siloed in each hospital. So can we find a way to create a general shared ledger to help us manage those records? And then also some people start to think about, can we use it to enhance insurance claim process? Like currently, this process are more or less manual. Can we put all of the records on chain and that computer just automatically speed up the process? And then some people propose just use blockchain as a general shared ledger to store biomedical or healthcare data. And then also some people focus on accelerate the clinical research using blockchain. So my study or the study in UCSD DBMI or Biomedical Informatics department are mainly focused on the fourth application. Right. Right. So any questions so far before I move into the use cases? All right, so if not, then I will get started. So these use cases are kind of like still quite new in its development stage. So but still, I'm happy to answer any question if you have any. So the first one is a data query. So the idea is traditionally many of the research data are generated in different health institutions, such as different universities like UCSD and others. So in order to use, but it's usually important to use the data generated from the other university or other institution. But then the process to get the data is actually quite, it's not quite straightforward. So we need to submit electronic forms, as you can imagine, need some like different levels of approval, and then make sure you are not using this data to do some malicious things, such as trying to re-identify the patients and then contact the patients, or trying to sell their data to other people, something like this. So it's kind of like a lengthy process. And also usually it requires kind of like a manual process, like people really take a look at your application and then extract the data you needed and then send it back to you. So it's more like a manual process with electronic forms submitted back and forth. So we are thinking about whether we can make it better by using blockchain. So the idea is now, instead of submitting those electronic forms, we try to put the request on chain. And then we write some code we call smart contract, which are the computer codes running on the blockchain to automatically determine what data to be extracted and then sent back to the researcher. So the idea is like we try to use this blockchain to log everything, log the transactions, and then we have this smart contract to automate the process. But then, of course, whether this query is valid will still depend on so-called institutional review board approval or data usage agreement. These are the legal entities who check whether people are allowed to use some data or not. And then once we have this done, as we can imagine, we can extend this architecture to even more universities, so that they can kind of like collaborate with each other, some kind of like the idea of like treaty, so that everyone can speed up the research process. So in order to build this blockchain solution, so this is our kind of like idea, but then in order to do this, our first step is then, of course, try to test on different blockchain platforms, because different blockchain platforms has its different characteristics. So to do this, actually, we did this in, I believe it's like 2 or 3 years ago, during the summer. So we have several graduate and undergraduate students. We try to build up several blockchain and then compare their kind of like performance and kind of like whether they are easy to learn or set up. So so what we did was eventually we picked 3 different blockchain platform, Ethereum, Hyperledger Fabric, and multi-chain. So, and then we summarize their kind of like some characteristics, technical features, and then we set them up to let students to try it. So as you can see, the setup is rather fast, usually within an hour, but the learning is kind of like longer, like can be as long as 2 weeks before being able to set up the first blockchain. So, but for some platform like multi-chain is rather simple. Like a student can usually learn it in 2 days and then set up in 30 minutes. So there are still a lot of like varieties of these different platforms. But then this is at least the first comparative study that we tried to get started with. Okay. So okay. So any questions for the first one before I move into the second one? All right, so the second one is about genomic data access login. So this is another application that we think blockchain might be useful. So currently, genomic data are stored in different repositories on multiple cloud environment, such as Google Cloud, Amazon Web Services, or Azure. So then people usually go up the cloud, apply for using this genomic data, and then they do some analysis. But then the issue is it is usually very hard to trace whether people really do what, whether the people do as they claimed, or they are doing something else. So the kind of like their data usage log is kind of like not that transparent, and it is like they have different format across different repositories and cloud, and thus it's kind of hard to trace who used what data for what purpose. So as you can see, if we can trace this, actually it brings us an additional benefits that it is easier to kind of like accredit other people. Like for example, suppose I use dataset X, then I should cite dataset X. But then without a way of tracing, it is kind of hard to see if I really cite it or not. So that's why we start to think about using blockchain. So how about let's set up another log across the cloud, across the repositories, so that everyone can see everything. So this is one of the benefits of blockchain, right? So everyone can see who use what data. And then it's more interoperable on the same platform. And then it's then thus more credible, because then we can make sure like the data sets are accredited properly. And then also we want to make sure this is adaptable. Like we are not kind of like replacing traditional log files. We just want to add another level on top of the traditional setting. So this is like, this idea sounds like probably doable, but again, in the real life, we want to see how practical this could be. So in order to do this, we actually organized a challenge 2 years ago. So we created this data set. So each data set contains, basically contains like 100,000 of records, and then looks something like this. At what time, which user did what to which resource on which site, something like this. So we have a lot of these records and then put them on 4 machines. And then we have a set of testing data as well. And then we set up 64 machines actually. And then we invite the teams from the world to join us to kind of like compete with each other to see who can make this happen faster than the others. So at the end, we have add teams, and then add submissions. And then so we ends up create a lot of machines on cloud, on Google Cloud, to test their solutions. So so as you can see, these are our final submissions. We have add submissions, as I just mentioned, and then whether the solution complete the test, whether if yes, whether the result is accurate, and then if yes, how about the insertion time, query time, disk usage, and memory usage. So as you can see, we can store 800,000 genomic data access records from 4 sites in 1 hour and query them in 3 minutes. So this is the best solution that we have at the time. So of course, this is definitely not comparable to traditional databases. This is way too slow. But the idea is by using this solution, we actually get the benefits of blockchain. It's immutable, it's transparent, it's provenance, it's source verifiable. And then also it is interoperable, and then can kind of like work without the need of a central server. So this is kind of like another area that we are investigating. So any questions so far for this one? All right, so if not, then I'm going to talk about the third use case, which is combining two kind of like recently popular technologies, machine learning and blockchain. So, so the idea of so-called predictive modeling is actually try to adapt machine learning algorithms in healthcare domain. So basically, we apply machine learning algorithms to try to predict patient outcomes. So as you can see, traditional machine learning algorithms, even including the latest deep learning algorithms, they can be used in a wide variety of applications. But then here, we specifically focus on predicting patient outcomes. So that we call this, so it has a specific name called predictive modeling. But then at the core, it's still machine learning. So we basically use data sources such as electronic health records. So when we go to hospital, basically we can see that our physician basically like busy typing our like symptoms and treatments and medication into the computer system. So basically we take the data from those records and then try to build machine learning models. So this is actually quite important for clinical research and patient care purposes. So, so let's see one example at UCSD Health. So for example, we want to predict a bed shortage, which is actually an important issue because currently, as you know, because of pandemic, like many hospitals kind of like reduce their operation time and then have some kind of like shutdowns, only open as needed. So kind of like we want to kind of like prevent this type of like bed shortage. So the idea is if we can predict long hospital stay, which long means larger than the third quintile of the patient staying time in the hospital. And even if we can do this prediction prior to a surgery, then we get a better chance to improve the facility usage, right? Because if we predict that, okay, tomorrow we will have several patients on surgery, and then afterwards many of them will need a bed. Then we probably can, and then we don't have enough room, then we probably can contact nursing facility, for example, and then try to kind of like prepare in advance to avoid such a shortage. So this is the idea. So so actually it's very straightforward. So here just a graphical like illustration of the process. We basically get the data from electronic health record system, the databases, and then we build predictive models, and then we predict whether new patients will have prolonged stay or not based on their previous records, and then we make some kind of like prediction and decision accordingly. Okay. So so with that, the idea is then this sounds like really good, right? But the problem is somehow we still need more data. So the idea is if some of you are familiar or heard about this machine learning, actually in order for it to work well, it requires some at least some kind of like basic amount of data. So for example, usually several hundred or even thousand or even more. But then, as you can see, even for COVID-19, such a big pandemic, as you can see, in a single day, in a whole UC health system, there are actually only 44 patients on ventilator. So you can imagine this is actually a very small number of patients. And suppose we want to build a predictive model on this data, then this data set is way too small for us to build a generalizable model. So we need more data. So then people may start to think, well, then why don't we just do some kind of direct data sharing, right? We can just let hospitals share data with each other. Then we have a large a patient base, and then we can build a better model. Yes, the idea is pretty straightforward and very intuitive, but there are some potential concerns for this approach, specifically re-identification. So a recent research showed that with only 15 demographics is enough to uniquely identify 99.98% of Americans, which means when a hospital deciding whether they want or not want share their patient data, they need to take this risk into consideration. So at the end, usually most of the hospitals are not really like very enthusiastic to share their patient data because of this sensitivity. And then if a patient data is leaked or breached, then there is a lot of penalty involved. So researchers start to think about a way to get around it. We want to build better model, but hospitals probably don't want to share data directly. So how can we solve this? So the idea is this privacy preserving machine learning. So the idea is instead of sending data to each other directly, here institute A, B, and C, they just pre-compute the machine learning model using their own data. And then they send their pre-computed parameters into a central site. And then the central site basically combine the machine learning model and then send it back to each of the institutes. So as you can imagine, in this way, the data never leaves their institution, never leaves their firewalls, so that they feel more safe. They just send aggregated parameters instead of sending the whole patient data. So it is way harder for some people to try to reverse engineer patient data from the aggregated statistic. So this is the idea. So in this way, we can build a better machine learning model without the need of sharing patient data directly. Okay, so I saw a question from Kevin. It is possible to try and gather more data samples by comparing results of COVID-19 to similar affecting viruses, even though the result will not match exactly. Sure. This is totally possible. And then this is actually how the hospitals are kind of like working around previously. Because at that time, like a few months ago, we are not that familiar. We are not understand COVID-19 that well. So at that time, people can only resort to like trying to find some kind of like treatment from flu or from some like lung diseases. So this is totally doable. But as you mentioned as well, like if we really want to get more precise targeted prediction, then we really need to focus on this specific disease. So in this example, suppose we want to really predict like patient outcome of COVID-19, then it's probably still better to just use the COVID-19 data instead of like using other data. But that's a workaround. Okay, hope this answers your question. All right, let's see. Here is another question. If data is aggregated, then it is based on predetermined aggregation rules. If researchers want to slice and dice data differently than what is aggregated, how would they do that? Oh, that's a great question. Yeah, so here, of course, if people really want to kind of like slice and dice data or look into some kind of like statistics, of course, each institution can still work on their own data. But similarly, we can also conduct this type of statistics across different institutions using similar technologies. So let me use a very simple example that I borrowed from our department chair, Dr. Machado. So suppose, so the idea is very simple. Suppose we want to know the average age of today's Zoom participants. So and then of course, all of us don't want to reveal our edge, right? So the idea is, how about let me start from me, and I just think about a random number, and then I tell this random number to Yash, for example, and then Yash add his edge secretly to that random number, and then tell Andrew, for example, and then Andrew add his edge, and then we do this for the whole people, so that at the end, the less people tell me the total the sum of these added edges, and then I can deduct it. I can minus it using the original random number that I thought of, right? And then we divide the total edge by the number of participants, and I get average edge. All right. So in this process, as you can imagine, at the end, all of us know the average edge, but none of us reveals our edge. So this is actually like a very, very simplified technique so that we can get group statistics without sharing data. So again, if we want to kind of like look into data into the patient level, then it is of course not doable. But if we are kind of like trying to identify some kind of statistic, like whether edge is more related to mortality or not, then actually we can use this type of techniques to kind of still keep the data within our institution, but still get some idea about the overall statistics. So hopefully this answers your question. All right, so great. So let me continue. So then, as you can imagine now, the issue will be like the model, because now we are relying on a central site. So for example, a model from institution A might be falsely recorded as coming from institution C. So if someone attacks the central site and modify the model directly, there's no way that we can even notice this behavior. So that's why we think about using blockchain. So by putting these partially learned machine learning models into the chain, actually into the transactions, we can actually avoid this issue, because now we use blockchain to submit, to kind of disseminate the data. So the idea is now we don't really have this central server, and then instead it becomes a peer-to-peer network. But the idea is, then how can we do the computation, right? Because now we don't have a central server. So our idea is, again, very simple. How about we just ask one of the sites to serve as a virtual server? So site 3 serves as both client and server, and the other people just serve as client. But then this simple mechanism still have some problems, such as then site 3 has a higher, like a heavier compute load when comparing to the others. So how about then we think about another solution as well? Then how about that? As you know, machine learning is usually iterative. So how about let's do it like for iteration 1, we ask site 3 to serve as a server, and then for iteration 2, we ask site 2, and then for iteration 3, we ask site 1 to serve as a server, so that we kind of like load balancing everyone, so that everyone can take a chance to serve as a server, and then we can jointly complete this computation without a physical central server. So this is like very simple idea. So we test this idea, we implement this and test it on 3 data sets, 2 publicly available data sets, the myocardial infarction data set, cancer biomarker data set, and another surgery data set at UCSD, which is actually the length of stay data set that I just mentioned. So actually we set up our experiment, and then these are the experiment results. So this is actually the running time. So as you can see, our solution called Glower Chain, the orange one, actually require more time. But then we can achieve the same predictive capability as the centralized version, the blue Glower. Okay, so kind of like we avoid the issue of central server, but then as you can imagine, now we don't have a central server to kind of manage, supervise everything. So we need more time to get consensus. Okay. So this is what we done last year. So we published a paper last year about this. And then follow up, we did some follow-up studies. So how about let's deal with the problem of so-called network of networks. So so previously we assumed that the network is kind of like flat. So we have a flat network. But then in the real world, sometimes it is kind of like a network of networks. So for example, there are 5 UC hospitals, UC San Diego, UC LA, UC Davis, UC San Francisco, and UC Irvine. So this is like a small network, right? But then you see the whole network could be a part of another national network as well. So it's actually in the real world, the network is not planned. It actually contains this hierarchical structure. So how can we deal with this? So we did this. So we conducted this study for, and then published another paper just this year. And then another thing that we considered is the site joining and leaving. So in our previous mechanism, as you can imagine, even if we ask someone to surface some site to surface virtual server, if this site leaves the network, then our algorithm might stop working. So we try to solve this problem by adapting another machine learning algorithm, a type of machine learning algorithm called online learning, so that the model can be updated in a sequential way, so that we can avoid the problem of site joining and leaving. So again, for the interest of time, I won't go into details of these 2 methodologies, but if you are interested, please take a look at our previous publications below. So, so to conclude, today we talk about blockchain, which is a distributed ledger for data. And then we talk about 3 use cases: clinical research data query, genomic data access login, and healthcare predictive modeling. So actually, we envision more interdisciplinary applications, such as the one that we work with Yash, trying to store COVID-19 questions and answers on the blockchain. So we are still working on that project. So that's why I'm not presenting it today, but that's another very important and interesting project as well. So I think that's the last slide of my presentation. So I would like to acknowledge all of my mentors, collaborators, and funding sources. So, and I would like to take any questions.
Yeah. Thank you, Dr. Kuo.
Thanks.
If anyone has any questions, please feel free to say so in chat, and we can have Dr. Kuo answer them. Okay.
Okay, thank you so much. Thank you, everyone. Thank you, Yash.
Looks like you had a question from Adwit, who said, "What was the most difficult question / problem you faced?
Oh,
and how did you work around it?"
Oh, okay, great. So I think that the most challenging part of this is like it's a new technology. So as you can imagine, for new technologies, when comparing to like more mature technologies, we get a lot of like implementation challenges. So I think Yash also know this well too. Like the programming language for blockchain smart contracts is not very mature. It's still very young. So it's kind of hard to implement when comparing to many traditional software platforms. So so we not only spend time to kind of like brainstorm the idea, design the architecture, but we also need to solve a lot of like implementation issues here and there. And then also the technology itself is also evolving. So something that we feel like unsolvable, probably like we saw a patch of the software platform next month, and then the problem is magically solved. So there are a lot of like things like this. But then I do believe, personally, I believe this is kind of like the cost of adapting new technologies. So it's not easy, but also very interesting and exciting. I think personally, I also learned a lot from this, based on this experience, especially blockchain is so different from traditional kind of platform or software. So hopefully this answers your question.
I had another question. What is a good program to start learning blockchain?
Oh, great. So, so the one that we are currently using, I believe Yash knows that is called Ethereum. So the reason why we use Ethereum is because it's a community-supported platform. So it's more like it's open source. Everyone can just download and run it. So the language on Ethereum smart contract is called Solidity. So there is also some kind of, Solidity is probably the most popular or kind of most common blockchain language or smart contract language for now. So if you're interested, then this is probably a good point to get started. And then we also use so-called Remix, kind of like online IDE, integrated development environment of Solidity to help us debug the code. So so probably these are like some kind of like starting points.
Yeah, agreed. Okay. John says what's up next. Okay, so the next talk is from Vice President of Artificial Intelligence, Patrick Bangart. But yeah, if there's no more questions for Dr. Su, we'll see you guys back at 4:30 for the next one.
Thank you.
Yeah, thank you, Dr. Kuo. Okay, yeah, we'll see you guys. Oh, what time is it EST? Let me stop. Okay, yeah, so